This is a video on how to find the relative maximum and relative minimum of a cubic function. And this particular problem comes from Advanced Algebra Unit 5, Lesson 9, Writing Equations. This is problem 4. In 4a, we were given the three roots of a function and asked to write the equation from the roots. And then in B, we're given a coordinate plane and asked to sketch a graph of the function. So I'm going to go ahead and from A, I have my function's equation. I'm going to go to my y equals menu. If there was anything here, I would go ahead and erase it. I'm going to put in my function. So y equals x to the third power plus 3x squared minus 2x minus 6. So what I would do if I were you, I would hit pause and make sure and put this in yourself. I'm going to hit graph. And I'm just going to verify because I was told the roots were -3, negative square root of 2, which is negative 1.4, and positive square root of 2, which is positive 1.4. So I just want to verify that my graph crosses the x-axis in the right spot. It looks like my y-intercept is -1, 2, 3, 4, 5, 6. So I'm going to jot down my x-intercepts, which I could write down from A, and without even, before I graph this. I'm going to jot down my y-intercept, so I could put it on my coordinate plane, and it looks like it crosses the y-axis at -6. I'm going to double check that by going to the table and going to -6, and it should have a 0 in the y spot. So let's go to our table. And sure enough, if you look at 0, the y is -6, so that also confirms to me that the y-intercept is at -6. So I can go ahead and get my 3 x-intercepts and y-intercept. I can get those 4 ordered pairs on the graph. And now I'm going to go ahead and put my relative maximum and my relative minimum on the graph. Or I need to find those ordered pairs and have the calculator do that for me. In order to do that, okay, the relative maximum is where the graph tops out and reverses direction, and the relative minimum is where the graph bottoms out. That's not the most mathematical way of saying it, and then turns back and starts increasing again. It's not necessarily the minimum, because the minimum is somewhere in negative infinity land, and the relative maximum is called the relative maximum because the actual maximum is off to positive infinity. So let's go ahead and find the relative maximum's ordered pair. You're going to hit trace. No, you're not. I take that back. You're going to hit second trace where it says calculate, and you're going to choose option 4, maximum. And then the first thing you need to do is use your arrow to the left and go to the left of the relative maximum. And you're going to hit enter. Then it's going to ask you for the right hand bound. And you're going to use the right arrow to go just to the right of the relative maximum and hit enter. And then it kind of gives you a guesstimate, but you're going to hit enter again, and then it'll give you the exact ordered pair, or the exact x and y coordinate of the relative maximum. So it looks like here -2.3 when we round, and for the y it's 2.3. So go ahead and jot that ordered pair down so we can get it on our coordinate plane. And now let's have the calculator calculate the relative minimum. So I'm going to go to second trace, which is, if you see up here in blue, it's calculate. I'm going to choose option 3, minimum. I have to now arrow to the right. And I'm gonna, when I get just to the left of the relative minimum, I'm going to hit enter, because that's my left bound. The calculator's asking for my left bound. Now it's asking for my right bound, so I'm going to go right to the right of the relative minimum. Hit enter. It gives me a guesstimate, but hit enter again and then it'll give you the exact ordered pair for that minimum. Looks like we're at 0.29 and negative 6.3 for the y coordinate. So go ahead and write this ordered pair down and we can graph this function on our coordinate plane. If you have any questions, please ask your teacher. Most importantly, practice this so you know exactly what you're doing before test time. Thank you.